Lesson 7.3, Rational Exponents. Our focused learning targets are I can evaluate and rewrite expressions involving rational exponents, and I can solve involving equations involving expressions with rational exponents. Our first vocabulary word is a rational exponent, which is when a term is raised to an exponent, and the exponent is a fraction. So our first example is 25, which is the term raised to the power of 1 over 2. The 1/2 is called a rational exponent. Here we have 27 to the power of 2 over 3. The fraction 2 over 3 is called a rational exponent. Next we have rational exponential form, and for any positive real number b and any integers m and n, where n is greater than 1, we can rewrite b to the power of m over n, rational exponent, is equal to 1 over b to the n to the power of m. From there, we can rewrite this expression as the square root with a root index of n, b, all to the power of m. B to the power of m divided by n is written in rational exponential form. And so how can we process a number like 25 to the power of 3 divided by 2? Well, we can say 25 to the power of 1 over 2 to the power of 3. And then we're going to go ahead and put 25 under the square root sign. And because we have a denominator of 2 in the rational exponent, it's going to be a square root with a root index of 2. And when we have a root index of 2, we do not put the 2 as the root index. And so then from here, how can you analyze this? This is, well, the square root of 25 is 5, so the answer is 5 to the power of 3. Right? And we can go ahead and calculate that out to be 125. Here's another example. A to the power of 1/2 is equal to the square root of a. Because we have a numerator in the rational exponent of 1, we have a square root. Root index is 2, the denominator, and a goes underneath the square root sign, and this is all to the power of 1. Right? But any expression to the power of 1 is the same expression. So a to the power of 1/2 is written in rational exponential form. So here we have a radical form, an expression written in radical square root form. We have b, our base, to the power of m divided by n is equal to the square root with a root index of n, the denominator, of b, all to the power of m. So this form here is written in radical form. Radical form. Here we have another one. We have a to the power of 1/2. This is the square root of a with a root index of 2, the denominator, and all to the power of 1, but power of 1 doesn't mean much, so we just say square root of a to the with a root index of 2. And this here is written in radical form. So we have rational exponential form, and we also have radical form.